Hello students, this is our vehicle dynamics class and in today's class we will discuss the topic of stability of vehicle. In the previous classes we have discussed the topic of stability of vehicle on a slope. But in today's session we will discuss stability of vehicles in a curved path. So let's start the topic. Before starting the topic, I want to tell you that this topic is very important from your exam point of view. So listen carefully to everything what I say so that you don't miss any point. So for example, look at this figure first. Suppose this is a four-wheeler which is approaching towards you. It is coming towards you and it is taking a turn in left direction, in this direction in which I am pointing my arrow. From the driver's perspective, it is taking a right turn from the driver's perspective. But if you see it from the front, it is taking a turn towards your left. This circle shows the center of gravity of the vehicle and the height of the center of gravity from the ground is h. H is the height of the center of gravity from the ground. Due to the curved path, due to the turn taken by the vehicle, the centrifugal force CF, the centrifugal force CF will be acting towards the right from the center of gravity. Okay, so this wheel is the inner wheel and this wheel is the outer wheel while the vehicle is taking a turn. Fi is the reaction force on the inner wheels. Fo is the reaction force on the outer wheels. Fwi is the friction force on the inner wheel. Fwo is the friction force acting on the outer wheels. This T is the wheel track, that is the distance between the front tires or rear tires, and X and Y represents the distance of center of gravity from the inner wheel and outer wheel respectively. Okay, first of all, you should be very clear about all the forces and directions of the forces given in the figure. Now let's discuss the topic. First one is lateral sliding. Lateral sliding means when your vehicle is taking a turn in left direction, its centrifugal force is acting in the right direction. So at what point this vehicle will start to slide in the right direction? The skidding phenomena, or we can say the sliding phenomena of the vehicle. Okay, let's see. A vehicle will skid or slide outwards when centrifugal force exceeds the friction forces. See carefully. When this centrifugal force CF, which is acting towards right direction, becomes greater than Fwi and Fwo, then your vehicle will start to slide or start to skid. Means CF and Fi, Fwi and Fwo is the point of balance. Means if your centrifugal force becomes greater than the sum of Fwi and Fwo, then your vehicle will skid towards the right side. Now, this Fwi can be written as mu Fi because you know that friction force is equal to mu into Rn, mu into normal reaction. So Fwi can be written as mu into Fi and Fwo can be written as mu into Fo. So this term has been replaced by mu Fi plus Fo, where mu is coefficient of friction, which are equal to mu W. So this Fi plus Fo, both this force Fi and Fo which is acting in upward direction is equal to the weight of the vehicle, W, mg, which is acting in downward direction. So Fi plus Fo is equal to W, and W is mg. So sliding will be about to commence when the force Cf is equal to mu mg. Means when your Cf, this centrifugal force, which is acting in right direction, becomes equal to the mu mg, then your vehicle will be about to slide. This equation. And Cf can be written as mv square upon r. This is the formula for centrifugal force. Mv square upon r is equal to mu into mg. Okay, so the force in the right direction is balanced by forces acting in the left direction. So from here we get this equation. From this equation we can calculate this velocity. First, m and m will be cancelled. Cancel out m and m. R is multiplied in the right side, and v, velocity, can be calculated as v square is equal to mu into gr. From this equation, v square is equal to mu into g into r, and velocity is mu gr under root meter per second. So this is your sliding velocity. Means if your velocity is greater than mu gr under root, then your vehicle will start to slide or skid towards the right side. Okay, while taking a turn towards the left side. From your side, if you see, from the driver side, the directions will be opposite. So now I want to, before going further, I want to tell you the basic formulas for the weight transfer. This is the formula for the weight transfer during sliding. So when your vehicle is sliding, there is a transfer of weight from the inner wheel to the outer wheels. When your vehicle is taking a turn and there is a centrifugal force acting in the opposite direction, then your transfer of weight will occur from the inner wheels to the outer wheels. So what is the formula for that is, now see, your transfer of weight will be directly proportional to height h and inversely proportional to the wheel track. So the transfer weight formula will be mu into W h upon T, where W is the weight of the vehicle, mu is the coefficient of friction. So mu mg h upon T will be the transfer weight during sliding. And if you're at the balancing point, if when the sliding ceases, this mu into mg, we have already seen that mu into mg is equal to centrifugal force. So mu into mg has been replaced by Cf, and Cf is mv square upon r. So these are the formulas for the weight transfer. Next, lateral sliding and impact will be discussed in the second part of this video. So thank you guys.